Welcome to this quick overview of Optical Power Meter Selection Guidelines. Many criteria need to be evaluated in order to select a suitable optical power meter. These include the desired test speed, the form factor for the instrument, the type of detector needed, and the choice of adapter for that detector. Speed is an important consideration in any test system, and especially in those used for production. The time it takes to clean and connect fibers, as well as setting references, is non-trivial and must be considered in implementing a testing approach. Most approaches can benefit with some degree of automation. Practical applications of automation depend on the required throughput and the mix of devices to be tested. Most power meters produce readings fast enough for cable production needs. Faster reading rates may be called for with stability measurements, performing environmental tests, or the production of certain optical components. One often has a choice between serial testing a single fiber at a time or testing many fibers at once in parallel. Serial testing is clearly slower, and that difference grows as channel counts increase. However, serial testing only requires a single channel power meter, so there is a cost savings in equipment. That savings often pales to the time savings produced by parallel testing, especially with ribbon cables. It is natural to consider mating a single channel power meter with an automated optical switch as an alternative to multi-channel power meter. However, the compromises of this approach rarely outweigh any slim cost savings it might produce. Precision switches are not cheap, but that is just the start. The detectors in the OPMs do not require direct contact with the fiber, whereas connections to the switches do, which creates an opportunity for damage. A power meter can accept both single-mode and multi-mode fibers, but switches can only handle one fiber type. Furthermore, switches don't offer universal adapters for different connector types, thus limiting your options for changing your test system. Finally, switches can have repeatability issues, and because of the extra connections, it would be difficult to accurately perform single-sided insertion loss measurements. OptoTest offers a range of power meter solutions. They all employ the same choice of detectors and provide equivalent accuracy as a result. The available channel count is the biggest difference between the units, as well as the available software. The multi-channel units are designed to fit in a standard 19-inch rack mount. OptoTest's portable solutions are convenient for troubleshooting. They travel easily to where you need to make measurements. All the portable units are USB powered and controllable via software. They also accept a wide variety of cable adapters. The OP500 series is an ideal solution for cost-sensitive applications. The OP508 and OP510 are basically the same, but the OP510 adds a 16-level readout for quick feedback. The OP712 is in a smaller package, but is still capable of supporting the OptoTest large area detectors. Benchtop models are popular for testing duplex and simplex cables. Up to 4 standard-sized detectors can be mounted on the front panel. Front panel controls are easy to master, and readouts are in absolute or relative units. The unit can also be controlled by software through its USB interface. The OP710 is a rack-mountable version of the OP735 that supports up to 24 channels of simultaneous testing. The internal display shows results for a single channel at a time, but the software allows viewing of all channels simultaneously. Its utilitarian design and high channel count make it OptoTest's most popular model. The OP740 is significantly different than the OP710. The most obvious difference is the color touchscreen display. While it uses the same detectors as the other models, it can take up to 125,000 readings per second. This makes it an ideal solution for stability measurements, environmental testing, and production testing of certain optical components. The touchscreen of the OP740 can be configured to suit your needs. In single-channel display mode, you can see channel information, range information, wavelength, and the controls. You can also choose to see multiple channels or all the channels. Color coding within the display makes pass-fail indication very noticeable. The optional software control lets you view all the channels at once along with the other relevant information. OptoTest has produced many custom test solutions for its customers over the years. Our software solutions can support racks with over 300 channels. The software supports simultaneous use of multiple OP710s or OP740s. There is also an available software development kit that lets you write your own customized applications for integration into existing test applications. The heart of any power meter is its detector. OptoTest offers 7 detector types and dozens of adapters. Detectors can be panel mounted or remotely mounted. Remote mounting brings the convenience of a portable solution to a benchtop or rack mount unit. You can take the detector to the DUT instead of the other way around. They also help eliminate unnecessary bends in the assemblies being tested. The 2 primary detector materials are silicon and indium gallium arsenide, or InGaAs. They each operate over a different range of wavelengths. There is some overlap in coverage that allows an InGaAs detector to cover single mode and most of the common multi-mode wavelengths. One can use a mix of detector types on a multi-channel power meter. It should also be pointed out that germanium detectors cover a similar wavelength as InGaAs. However, they are not preferred due to their poor temperature stability and sensitivity to small variations in source wavelengths around 1550 nanometers. Detectors come in several sizes. The 1mm detector is the most common one used for single-mode fiber. It is also suitable for multi-mode with numerical apertures less than 0.275. The 3mm detector is the most versatile detector as it supports all simplex fibers and can even measure duplex and ribbon cables by adding an integrating sphere. The numerical aperture mentioned in the previous slide is a unitless number that characterizes the range of angles for which a fiber can emit or accept light. It is calculated from the refraction indices of the core and cladding. The beam leaving the fiber should fit within the area of the detector. A 1mm detector may be too small for some multimode fiber with a numerical aperture greater than 0.29. This is why 3mm detectors are considered the most versatile. Integrating spheres are a simple and cost-effective method to use a standard-sized detector with multi-fiber assemblies such as MTP, MPO, ribbon cables, and duplex cables. Magnetic and screw mounting is available, as well as a large selection of adapters for different connector types. Large area detectors allow one to test duplex and ribbon cables without the use of an integrating sphere. Here we see an MTP MPO connector with 24 single-mode fibers. The gray box is the approximate size of a 5mm detector. The red dots show where the fibers shine on the detector. It should be noted that each fiber will still need to be excited independently because the detector cannot discern the power from the individual fibers. Large area detectors feature convenient magnetic mounts that allow one to quickly change between termination types. The OP710 and OP740 can fit up to 6 large detectors per box. The OP735 can fit only 1. Here we see a comparison of the different power ranges for each of OptoTest's detector options. The power levels are displayed in dBm. The 5 bars on the left represent the InGaAs detectors. The 2 rightmost bars are silicon detectors. The 2mm InGaAs detector is a high-power detector with a max input of 27 dBm, or a half watt. While it has over 80 dB dynamic range, it is best suited for testing sources. For testing assemblies, the lower-powered detectors are typically more suitable. The adapters on OptoTest power meters are interchangeable. There is a wide variety to choose from, and more are always being added. If you don't see the connector you use in the next few slides, it doesn't mean we don't have it. This slide shows our standard adapters for our smaller 1 to 3mm detectors. The optical black connectors are the same size as the standard adapters shown previously, but have black painted interiors to ensure outside light and reflections won't influence critical power measurements. Here are the available adapters for OptoTest's integrating sphere. Note that there is even an adapter for bare fiber. These are the magnetically mounted adapters available for the large area detectors. Their larger size limits the number of these that can be placed on a power meter. Choosing a power meter requires knowledge of your DUT and test speed requirements. Smaller form factors are cost-effective but may not offer the higher throughput that higher channel count units can. The detector type will be based on the wavelength, while the size would be based on the power range or the type of cable being tested. OptoTest offers a full range of power meter solutions from portable units to fully customized and automated rack mount solutions. Let our experts help you specify your next optical power meter.